Number 6.
All right. So stars one type of this and 2 different continues. $20,000 milligram.
Okay.
Or,
Yeah, the secret with these is to get your units. I mean, you're going to run into all kinds of problems in math where you have to do numerous unit conversions. Okay? Well, they want to know how many milligrams are in 2 decagrams, so we would like to end up with milligrams per decagrams. Well, we know that there is 10 grams per 1 decagram, and notice that I made that 10 over 1, not 1 over 10.
mm-hmm.
In other words, I want grams in the numerator. And then if I multiply that by the other conversion factor of 1,000 milligrams per gram, now I notice my grams cancel out and I have milligrams per decagram, which is 10,000. One too many zeros there. And that's milligrams per decagram. So how many milligrams are in 2 decagrams? 20,000. But the real secret of the problem is to always make sure your units, in other words, you can solve the problem by knowing units alone and making sure. When I say there's 10 grams per decagram, that means there's also 1 decagram per 10 grams. And I can write it however I want. I can also write the second one either way. Well, depending on how you write it, depends on what you come up with in the way of units. Number 7. Always remember to look at your answers before attempting to do the problem. So that immediately tells you that the vertical axis is number of installations. Just the question is it in tens, hundreds, thousands, or tens of thousands?
Mm-hmm.
What is it? Yeah, if the total is 27,000, then that must be 9,000, 5,000, 6,000, and so forth.
Yeah.
All right. This next one is a favorite of mine. Only because it cost me a 7th grade student. I had a new student call up from Florida, wanted tutoring for his 7th grader who was taking algebra. His 7th grader comes on and he gives me a problem very similar to this. And I solve it the way I solve all absolute value problems. In other words, what I did was I said n minus 1 equals minus 1, or n minus 1 equals plus 1. Isn't that the way I've taught you how to do them?
Mm-hmm.
Well, this provides a solution of n equals 0 or n equals 2. And the question is, do either of those solutions work?
The n minus 1 equals -1.
No.
Oh, wait.
In other words, I came up with two solutions. I came up with that
One
one.
of them can't work because it's the opposite.
Which one works?
Neither.
You got it. There's no such value of n. And what I failed to recognize is that you can never have the absolute value equal to a negative number. That's impossible. Absolute values, by definition, are always positive numbers. And I didn't spot it right off the get-go. And the funny thing is that the 7th grade student's mother, who was a teacher, was listening in on the session. And she stopped me immediately and challenged me when I came up with my solution because I failed to check it. And she says, well, this is not what his teacher has. And then I realized my mistake and that you have to be a little careful when you're doing absolute value problems. It's one of the few problems where it's possible that both solutions don't work. Usually with these kind of problems, you get one solution maybe that is extraneous, and you don't find out about it until you actually do the problem. But this problem allows you to completely do it through normal techniques. You come up with that solution, and it's easy to go on to the next problem. But if you check either of those solutions, neither one works. And it's because the absolute value of something can never be negative. So this instantly has to be no solution. It doesn't matter whether it's x or n minus 1. The fact is that that part can never be equal to -1. And I never heard from that student again, that 7th grade student. No, his mother came to the conclusion I didn't know what the hell I was doing. I don't blame her. Just shows you can't make very many mistakes in life. All right, questions 9 and 10 are with regards to that equation you see at the top left. A equals 1052 plus 1.08t. Solve that for t. And that's what equation 9 says. What do you get when you solve that for t?
Get A.
No, I don't think. Oh.
Because A isn't negative.
No, you're right. I don't know what I was thinking. I was looking at it wrong.
Oh, good.
Yeah, no, A is fine. And then number 10. Here, I need to put the number, I need to go up to show you the equation. So at which of the following air temperatures will the speed of sound be closest to 1,000 feet?
What are all the answers for 10 again?
Well, they're saying, here's the original equation. And they say, for what temperature of T will A be equal to 1,000? Well, for A to be equal to 1,000, it's 1,052 plus this. So minus 46 looks like it might work. 1.08 times 46 equals 49. Now, how about 48? 1.08 times 48 equals 52. In other words, a t of minus 48 makes A equal to 1,000. About number 11. Now, to be able to answer number 11, I think the easiest way to answer it is just to solve that.
Yeah.
Go ahead and solve that. What do you get?
You get x is less than or equal to -2.
So you get this, right?
Yeah.
Which answer is not a solution? This can be a little tricky. I've always found it to be a little tricky.
So it can't be -1.
Right, exactly. These are tricky because x is on the wrong side. In other words, if you have an equation and x is on the right side, no big deal. I mean, it just isn't any big deal. I don't care whether x is on the right or the left. But if I have an inequality and x is on the right, it's hard to look at that. It's just hard to do it. So if you want to put x on the left, go ahead and do it, but change the direction of the sign so that you end up with that. Well, now if I tell you that, it's easy enough to figure out that B is correct, C is correct, and D is correct. A is the only one that does not satisfy that. Just always remember that if you switch the x and the number, you have to switch the direction of the inequality. Number 12.
Is it 6?
Well, this is another strange problem that they don't usually ask you these kind of problems given that kind of a chart. I presume you got 6 by adding up 2, 4, 1, that's 7, that's 9, that's 12, and there's 1, 2, 3, 4, 5. 12 divided by 5 is not an answer, so that's not the way to do it. Let's see. If we figure out the total number of seeds, we get 3 times 2. We get 5 times 4. We get 6 times 1. We get 7 times 2. And we get 9 times 3. And if we add up those numbers, we get 32, 46, 73 apples.
Okay.
Which is the closest to the average number of seeds per apple? There's 12 apples. Huh. It's that number divided by 12. Five. This is a tough one. Why is this so tough? I guess you need to figure out how many.
By 12, wouldn't that be 6?
Yeah. In other words, there's 2 apples that have 3 seeds. So that's 6. There's no apples that have 4 seeds. But there are 4 apples that have 5 seeds. That's 20. So this list of numbers that I have over here is your total number of seeds. And we get 73 seeds. Number of seeds in each of 12 apples. So we got 73 seeds per 12 apples. That's 5 1/4 seeds per apple.
But 72 divided by 6 by 12 is 72.
Excuse me. It's 6 1/12. So the answer is 6. You're absolutely right. Sorry.
No problem.
Yeah. Even still, that's a tricky problem. I think just because of the way they lay it out. Even if you do your division correctly. Hold on, let's see. Calculator portion. I guess when they tell you calculator portion, you can probably assume you're going to have to use your calculator.
Yeah.
In other words, it's going to be helpful to use a calculator, which you can't always say about all these problems. I've run into very few problems on the SAT where it's correct to use a calculator. There are not that many. It's almost a illusion that you're better off if you use a calculator. You're really not. Except on this section here. So how many? Which of the categories accounts for approximately 19% of everybody that responded? First of all, how many people responded?
310.
Okay. So what number divided by 310 equals 0.19? Well, what's 0.19 times 310? That's a 0.19 times 310 equals 5/8. So x equals 58.9. Which category is that?
It's the geometry male.
Males taking geometry, yeah. Okay. Gosh, I think this is as far as I've ever gotten into this test. I've never gotten to this problem before, which is odd because I'm working with a few people that are going to take the SAT. I incidentally have 3 more practice tests online to use, so I got lots of SAT questions. Of the new SAT, I got all kinds of. I got like 8 tests of the old SAT, but there's a considerable difference. All right, this is kind of a good one. First of all, read it and tell me if you don't understand what they're talking about. Got 21 measurements.
It's going to be the mean. Or would it be...
I have 20 measurements. If I take out the 24, and my mean is going to be somewhere between 8 and 16. So taking out the 24 affects the mean by at least 8/20. 20, in other words, the difference between that 24 and the next lowest number is 16. So I'm going to lose 8. And divided by 20, that's how much I'll affect the mean.
Okay.
Now the median is the middle. Well, what's the middle approximately equal to now?
I believe it's 12.
I think so. And if I take out the 24, what's it going to be?
12.
Probably. Yeah. In other words, it doesn't affect the mean hardly at all.
Yeah.
Range. What's the current range?
Current range is 16.
What's the range after I take out that outlier?
8.
That's a difference of 8.
Yeah.
It appears that that's the one that's going to be affected the most, would be the range. And that kind of makes sense when you look at these things. Outliers, if you look at everything as a normal distribution curve, outliers are way out there or way down there. Okay, so if I eliminate an outlier, the range doesn't go from this point to this point. It goes from that point now to that point, especially if it's an outlier that's really a long ways away. So the range definitely gets affected by that amount there. They will all change by the same amount. No, they won't. All right, let's see. Is that a good place to stop, Cole?
Yeah.
All right, we got through number 14. Cole, I'll talk to you next Monday.
Talk to you next minute.
Bye-bye.